Hello everyone. So let's start solving today's problem. Subarray with given sum. And in this problem, we have been given an unsorted array of size n, and all we have to do is to find the continuous subarray that adds up to a specific number that has been given as s. And at last, we have to return the indices from left to right. Okay. So if there is no element exists, then we have to return -1. So let's look upon the first test case in which we have been given s equals to 12. So one approach you can think of is using a nested loop. Means you will be first, your I will be traversing from start to end, and you will be placing your I here and then calculating the sum through the second loop j. And when whenever your sum equals to your given sum means s, you will simply return I and j. Okay. But here we're going to discuss the optimum approach. Okay. So what we'll be doing is we'll be first keep on adding all the elements. Means I'll be using sliding window approach, which is expected in this solution. And both I and j will be pointing to the start, and my j pointer will move in forward direction to increase the window size. And my I pointer, whenever my sum exceeds s, will be decreasing the window size. Okay, so for example, let's demonstrate 1, 2, 3, 4, and 5. So first I is here and j is here. So first my sum initially is 0, right? So since my sum is 0, I will add the element, add very first element. So now my sum becomes 1 and my j pointer moves here. Okay, now I will add this 2 since my sum is still less than 12. Okay, so it will become 3. Again, I will move j and add. This will become 6. Again, I will move my j. It will become what? 10. Again, I will move my j and it will become now 15. So as soon as it becomes 15, I will have to reduce the elements, right? Because my sum has exceeded s. Since my sum is is greater than s, let me erase this. Since I will start eliminating. So what I'll be doing is I will decrease from the left pointer, which is I. Okay. As I said before, I'll be using I as to decrease the window size. Okay. So then I will be moving I forward direction. So I will first eliminate this one from 15. So it will become 14. And my I will point on to 2. Again, my sums 14 is still greater than 12. I will again reduce it. It will become now 12. And my I is here. So what I have to return is this is 2 to 4. So since this is one based indexing, I will have to return from this 2 to this 7, right? 5, 5 plus 7, 12, right? Okay, so I took the wrong example. I noted it incorrectly, but that's fine. I hope you get the intuition. So let's see what we are going to do. First of all, we are initializing our sum variable to 0. Then if in any case, this is an edge case when our given sum required sum is 0, then in that case we'll return -1 since we are expected to return -1 in any invalid case. So I have initialized my left and right pointer, I and j. Here I have took it L and R. So this is the while loop condition so that my R and L don't exceed the size of the array. And if my sum that I have been calculating is equals to the given required sum, then I'll simply return L plus 1, comma R. And in any case, my sum is less than S. That means that I need to add the elements in my sum. So I'll simply add it and increment my R. In case my sum has exceeded, I will simply eliminate the elements from the left, decreasing the window size, and I will increment L. And if this these if else ladder doesn't get doesn't return value, doesn't returns any value, I'll simply return -1. Okay. So let me show you that it works fine. Okay. Thank you.